I think this is page 27 in your packet. 29. No, okay, you're not right. It's page 29.
What?
That helped me out a little bit. Instead of the thread. So page 29. The first 5 problems on here, really it's 3, but 5 parts, are just a review of the material that we've been going over. So the first 2 problems, can you solve those equations? Number 2 is factoring. Can you factor them? And then the last one is just a little like think about it problem, what's going on with it. So see if you can complete those group of warm-up problems.
Oh, sorry.
So how do you solve the first problem when you have something squared? So we have x minus 5 quantity squared equals 2, 8, or 49. How do we solve that?
Take the square root of both sides.
Right, take the square root of both sides. So factoring is an option. You could FOIL that out, set it equal to 0 and factor it. But the problem is that they're not all going to be factorable. So what happens if you do all that stuff and then you can't factor the problem? Completing or taking the square root makes it really straightforward because you already have a quantity that's by itself, it's already squared. So if we take the square root, it eliminates the squared term on the left, and on the right you get, and what goes in front of that 7? A plus or minus. Why do you need the plus or minus? Can anybody answer it? Because you square rooted it. It initially was something squared, and when you have a graph that has a x squared in it, what kind of graph does it make? Yep. So that plus or minus says that you have a number on the left and the right of the parabola because there's 2 values on each side of the axis of symmetry. Other questions? So Kate, the 2 answers that you have for x would be?
X equals 12 and x equals, I didn't get this far, sorry.
That's right.
X
So,
equals 2,
yep.
right?
So we're taking 5 plus 7 and 5 minus 7, which is negative 2. So adding the 5 to the other side, 5 plus 7 is 12, 5 minus 7 is negative 2. So the second problem, we have x plus 6 squared equals 20. So if we follow the same process, take the square root of both sides. Unfortunately, 20 doesn't have a perfect square, but there is a number that we can break it down. Nicholas, how would you break down the square root of 20?
You put into 4 square roots of 5.
So that
Or
becomes
2 square roots of 5.
2 square roots of 5. Again, plus or minus. Anytime you take a square root, to get that x squared term to be by itself, we need a plus or minus in front of it. So the final answer in this case, if we take the 6 to the other side, it's negative 6 plus or minus 2 square roots of 5. Because this is a square root problem, you can't combine them together any further. So this stays as plus or minus 2 square roots of 5. That means that this problem, you wouldn't be able to factor. So if you get an answer that is not a nice whole number or a nice fraction and has a square root in it, it wasn't factorable. Questions? The next two problems, these have something in common. When you factor them, x squared plus 18x plus 81. What's special about these problems? Virginia?
81 is square and 18 is
Yeah, so this is that square root pattern. So 81 is a perfect square. You can take the square root of it. And 18 is 2 times that square value. So 2 times 9 is how we get the 18. So Virginia, how would you factor it then?
I factored it into x plus 1 squared.
Right, so that is x plus 9 squared. So if you chose to multiply a times c and got 81, you're still taking 9 and 9. And you would have x plus 9 times x plus 9. But it is a perfect square pattern. So once you recognize that it's a pattern, it's just x plus 9 squared. So knowing that, if you look at letter B, that would factor as,
X minus 11 squared.
okay, so x minus 11 squared. 121 is a perfect square. It's 11. 22 is 2 times that value. So number 3 says 27 plus some number is 6 squared. What's that number? Here, 9. If you wanted to kind of think of it as an equation, it would be 27 plus some number, which is just x, is 6 squared. So 6 squared is 36. So 27 plus 9 would be 36. Questions? All right, so completing the solve the equation by finding square roots. So we have x squared minus 8x plus 16 equals 25. One of the ways that we could solve this would be to set it equal to 0 and try and get it to factor. So that's one way to try and approach the problem. The other way that we can approach the problem is to try and make the equation a problem that we could use square roots with. And that's what we did for the first two. So if you look at these first two problems, we took the square root because the left side has a parenthesis squared, the right side just has a number. So we're going to see if we can change the way the problem is written and then take square roots to solve it instead of factoring it. So if you look at the left side, how could you factor the left side of the equation? And just the left side. So I don't want you to get it equal to 0 and try and break it down and factor. Sam, how could we factor the left side of the equation?
X minus 4.
So the left side of the equation would factor as x minus 4.
And the other side would be 5.
Just before doing that,
Oh, okay.
it would be x minus 4
Square.
squared. So the left side of the equation factors as x minus 4 squared. If you notice there's something special about a piece of the equation, you're allowed to factor that. You don't always have to have it set equal to 0. Because in this case, if we have x minus 4 squared equal to 25, we can solve this equation by using the square root method. So instead of the traditional factoring, you can still factor it, but then approach the problem and solve it a little differently. So Sam already took the square root of both sides, and Sam, you said x minus 4 would equal
5.
5. What goes in front of the 5?
Plus minus.
Oh, plus or minus. So x minus 4 would equal plus or minus 5.
And then x would equal 9. X would equal 1.
Right, so when you add 4, 4 plus 5 is 9. 4 minus 5 is negative 1. So it's just kind of changing the form of the problem by using the fact that the left side was a perfect square and then trying to solve it using the square root method that we've been talking about the last couple of days. So you still could have factored that problem by setting it equal to 0 and using AC grouping, but this is another way that you can solve it. So it's giving you different options depending on the type of problem you have, the numbers that are sitting in it. It only works because of the 16 being a perfect square. If it wasn't a perfect square, then it wouldn't work for us. But it does because of that 16 being a perfect square. Questions? All right, so we are going to work on a process called completing the square. Meaning our goal is to come up with problems that always have a perfect square on the left side, that third C value. So can we create our own problems that have that number that force it to be a perfect square? So completing the square is a process of transforming or changing, whatever word you want to use there, the left side, bless you, to be a perfect square trinomial. So perfect square trinomial are the two values that are the two problems we just looked at. So perfect square trinomial, x squared plus 18x plus 81, or x squared minus 22x plus 121. Those are perfect square trinomials. Trinomial means it has three pieces. That back number is the perfect square that we're looking for, so the perfect square trinomial. So there are a couple of steps involved in completing the square. This is kind of like, not a proof, but like a logical process as to how this works, and then we'll work through the steps that are involved. But to complete the square for the expression x squared plus bx. So if you have, let's go back to this problem right here. We have x squared minus 8x. Our goal is to come up with this c value. Now it was given to us as 16. But how do you get that number to be 16 from what's already there originally? Yeah, so you take this middle number, that's b, and you cut that in half. So if we cut negative 8 in half, Virginia, you get negative 4. But how does it become 16 then? Multiply it by itself or square it. So to get this number to be 16, you take your b value, cut it in half, which makes it negative 4, and then square it. Any number squared is a positive value. So just looking, again, you don't have to write this down, but just to get you to think what's going on here. To get this 81, you have 18. If you cut 18 in half, you get 9. 9 squared is 81. Negative 22 cut in half is 11. 11 squared is 121. So that's how that value is being created. There are reasons why those numbers are in the problem and why they're working that way. So it's not just, oh, those are the numbers we were given, it just happens to be like that. But there is a mathematical reason as to why those values are created. So to complete the square for x squared plus bx, you add b divided by 2 squared. So the center number is b. You cut that in half, you square it to get a value that is a perfect square. So algebraically, if I have x squared plus bx plus that b divided by 2 squared, that number, the 16, the 121, the 36, whatever that value happens to be. If we're factoring it, we would factor it as x plus 1 b over 2, x plus the other b over 2. Because it's a perfect square. So if something's a perfect square, I should have double of them. B divided by 2 times b divided by 2 is that quantity squared. Or we could write it as just that one quantity in parentheses, which is really our goal. What's that perfect square quantity? So this is kind of the logic behind it. It's not essentially a proof, but that kind of gives you like a mini proof as to what's going on with the problem. So at the top of the next page, we're going to try and make a perfect square trinomial. So that means I want to have 3 terms, and I want it to be a perfect square. So the steps to doing that would be to take half of the coefficient of x. So whatever number's in front of x, that's our b value. We want to take half of that. So that means take b divided by 2. We're going to use the result of step 1. I'm sorry, not use. Let's square the result, not use. Square the result of step 1. Or really that means take b divided by 2 squared. That is my perfect square value. We will replace c with that value and then factor it into a perfect square. So I know there's 4 steps, but really it's like a quick maybe 2 things that you're thinking about. So we have x squared plus 12x plus c. Our goal is to figure out that number to make it a perfect square trinomial so that we can break it down and factor. So what you're thinking about is you're taking half of the coefficient of x. Well, that's b. So if we take half of b, that's 6. You're taking that number and squaring it, which is 36. That becomes our c value. So x squared plus 12x plus 36. So that's how we get it to be a perfect square trinomial. And then the last step would be to factor it. Well, now that I have it as a perfect square, we can break it down as a factored form. So Sarah, how does that factor?
It would be x plus 6.
Yeah, x plus 6 squared. So if you look at letter B, we have x minus 24, x squared minus 24x plus c. Again, our goal is to figure out the number that completes this, that makes it a perfect square. So you're taking negative 24, cutting it in half, and then squaring it. That's really what you're doing. So b divided by 2 squared. So Caitlin, what is b divided by 2 squared? 12. So 12 squared is 144. So x squared minus 24x plus 144. Or it factors as x minus 12 squared. So I believe there are just a couple of review problems down there. So the first two, solve the equation by finding square roots. So what would you do for the left side? Think, what do you have to do to the left side of the equation so that you can take the square root of that? And then the two underneath that are just completing the square for that c term. And then we'll actually see, can we work through a full problem to try and solve for x? Because that's the goal. Can we take an equation to try and use this completing the square to solve for x? Letter A says x squared plus 6x plus 9 is equal to 36. So Ryan, how would we break down x squared plus 6x plus 9?
Take 6, divide by 2.
What would the answer be as a factored form?
X plus 3 squared.
Good, x plus 3 squared. You were right. Good. So we have x plus 3 squared equals 36. And then to solve it by finding square roots. That means in order to get rid of the term that's squared, we're taking the square root of both sides. Ryan, the square root of 36 is 6, and we're putting a plus or a minus in front of that. So if I subtract 3, we have negative 3 plus or minus 6. So Ryan, negative 3 plus 6 is?
What, 3?
And negative 3 minus 6?
Negative
Awesome. So two answers are 3 and negative 9. Jenna, the second one, we have x squared minus 24x plus 144 equals 100.
X minus 12.
And then if we take the square root of both sides, you end up with x minus 12 equals plus or minus 10. So x is equal to? And 2. Good. So you take 12 plus 10 and then 12 minus 10. So the 12 is first, you're adding 10 and you're subtracting 10. So 22 or 2. Questions? So then to complete the square, finding the value that makes it a perfect square trinomial, We have x squared plus 22x plus the c value. Kate, what did you get for c?
I had 1.1, so x plus 22 equals 1.1.
So this would be x plus 11 squared. So you're taking the c, 22, divided by 2, square that number. Sam, how about x squared minus 9x plus c?
X squared minus 9x plus c. I got stuck on this one.
Okay, this one's a little trickier, right?
Yeah.
So if we take negative 9 divided by 2 and square it.
Negative 4.5.
So I don't want you to convert it to a decimal.
So then
How would you square a fraction?
square root both those.
Hold on, just how would you square negative 9 and 2? So square both of them. What's negative 9 squared?
81.
81. What's 2 squared?
4.
4. So that becomes 81 over 4. So when you go to factor it, what number goes in the factored form? So here we used 11 because the square root of 121 was 11.
Use, negative 9.
Yeah, you used negative 9 halves. Nice job, Sam. So we used 11 over here because the square root of 121 is 11. So if I have 81 over 4, the square root of 81 over 4 is 9 halves. This number right here, that's the number b divided by 2. We square it to make it the perfect square. So if I'm not squaring it, it's that negative 9 over 2. A little trickier with fractions.
Do you really have to find C, or can you just find
Well, the problem said make it a perfect square trinomial. So
Okay.
yes,
But like technically to solve it?
technically solve it now. Other questions? A lot of important people just walking by. They look pretty important. All right, so at the bottom, now we're going to try and do this entire process. Can we pull all these pieces together so that we can complete the square and then solve the problem? So that's the final goal. Like getting it into this completing the square form. Yeah, we're getting it factored, but now can we use that factored form to try and solve the problem? So we want to be able to solve for x. So we've got x squared minus 10x plus 13. The first question for anything is start with factoring it. Can you factor this problem? No, because if we have a 13, the only factors of 13 are 1 and 13. They're never going to make a negative 10. So you can't factor it. That's why you have to come up with another way to solve it. So how else can we try and get the x value? To find the x-intercepts, to solve for x, to find the zeros, we need another approach. And that's why the completing the square kind of exists so that we have another way to solve it. Virginia. So the first step says eliminate c by adding it to both sides. The 13 isn't a perfect square. So we need to get it out of the problem because it has to be a perfect square for us to be able to factor it as a perfect square. So take the 13 to the other side. So by doing that, we end up with x squared minus 10x. That's that x squared plus bx. That's what we need to get a perfect square. And then you're going to leave yourself a little space because we're going to be plugging in a number c to make it a perfect square. Now we have an equal sign where the other problems didn't have an equal sign. We put the 13 on the other side, so we need a negative 13. I'm also going to add a blank past that 13 because if you put something on the left side of an equation, you need to put that same thing on the right to keep it equivalent. So whatever number I plug into the equation on the left, we have to plug that same number on the right. So part 2 says find b divided by 2 squared and add it to both sides. So we need to make sure we're doing things to both sides because it's an equation, it needs to be equivalent. So b is negative 10, divided by 2, square that number. So that would be 25. That's the number that completes the square. So we're going to add 25 on the left. But because it's now an equation, we also need to add 25 on the right. So whatever you do on side, you got to do the same thing to the other. Now, if you look at the left side, this is a perfect square trinomial. So Sarah, that factors as
X minus 5 squared.
x minus 5 squared. And on the right side, Sarah, negative 13 plus 25 is 12. So now we have a problem that we can solve using what? How could we solve this? Virginia?
By
By taking square roots. So completing the square is like the precursor to using the square root method. So we're forcing the problem to look like something we can then take the square root of. So completing the square is the first part. Now we can take the square root of both sides to continue to solve. Virginia, how does 12 break down?
It would break down to 4 and 3, so plus or minus 2 square root.
Perfect. So plus or minus 2 square roots of 3. So when you get x by itself, if I take the 5 to the other side, we would add 5, have the plus or minus, and then 2 square roots of 3. Questions? So I want to try and get one more problem in. If you flip to the top of the next page, just want to make sure everybody feels a little more comfortable by working through. So the first thing, the c value, you need to take it to the other side. We're only looking at the x squared and the 6x. So we would have x squared and 6x. I like to leave myself a little space because you're going to be plugging a number in there that's a perfect square. The 4 is on the other side. Second step is to take b, that's 6 divided by 2, and square it, because we now need to complete the square. So Sam, 6 divided by 2 squared is?
6 divided by 2 squared. That'd be
9. 6 divided by 2 is 3. 3 squared becomes 9. When we factor the left side, we end up with x plus 3 squared equals 13. Now we can take the square root of both sides and continue to solve to get x by itself. So we get a plus or minus square root of 13 because 13 doesn't have a perfect square, and then subtract the 3 to the other side. Anyone have questions? This is one of my favorite ways to solve. I prefer this to factoring. Any problem you can use completing the square with. It works for any type of quadratic problem. So it's something that you can always use or revert to.